So in this presentation, the communication architecture of the Abdolinezhad project will be discussed. So more specifically, we will talk about secure and reliable communication architecture of the Abdolinezhad project. So the table of contents is as follows. In the beginning, there will be an introduction. In the introduction, we will discuss about the system use case, the communication requirements, and the security requirements of the communication. The next step is architecture of the communication system. And in this topic, we have architecture description, roles and the components of the architecture, primary and secondary communication, interfaces and protocols. The next topic is security design. In security design, we will talk about security considerations, security domains, and security implementation. Then there will be interface commands and requests, and then implementation of the communication system, and the integration, and in the end, a summary of the whole project. So in the beginning, we want to talk about the system use case. As you can see here, this picture here shows the overall use case of the system, which consists of 10 steps. So in the first step, a van gets loaded in a depot. Then in the second steps, the van autonomously drives to the meeting point without any driver. In the third step, the courier gets on the van at the meeting point. And in the fourth step, the courier drives the van to the delivery area. Then the courier takes some parcels from the van and delivers them to the area. Then when the delivery is finished, the courier calls the van to the new location. When the new location is set to the van, the van autonomously drives to the new location and meets the courier there. The courier gets another set of parcels and then takes them to another delivery area and performs the delivery. And this step number 6, is performed several times until the parcels are finished. And when the parcels are finished, the courier drives the van to the departure point. At the departure points, the courier leaves the van, and then the van autonomously drives to the depot. And at the depot, the van gets unloaded if some parcels are still remaining. And in the end, it's sent to the parking. So this is the whole overall use case of Abdolinezhad system. For such a system, we want to talk about the communication requirements of such a system. As we saw, there is some entities in the system. The system entities are couriers, which are the users of the system, and their task is to deliver the parcels to the in the delivery area. Then there are several vans which take the parcels from the depot and takes them to the delivery area. Then there is a need for a backend system which monitors and supervises the whole delivery process. So this is these are the Abdolinezhad system entities. And what are the communication needs of such a system? One need is that the courier should be able to get the updates from the van. If there is an error in the van or its location, its speed, and so on. The courier should also be able to send commands to the van, for example, to send it to a new location. Whenever there is an unexpected situation with one of the vans, which cannot be handled autonomously using with the van. So at these situations, there is a need for a backend system to monitor the vans and handle such unexpected situations. And moreover, there is a need that the courier should be able to update the fleet management system or the backend system with the delivery status, if the parcel is delivered or not, and so on. So then we talk about the security requirements. The first and the most important security requirements of such a project is that the communication of the system is on the public network, which of course is unsecure because it's public to everybody and everybody can see the commands and the data which is transmitted. So there are some potential attacks when we work on a public network. There is the possibility of data leakage, denial of service attack, data tampering, unauthorized access, and also fake entity injection, and so on. So in order to design such a communication system, you can see here the overall architecture of the system. So the system consists of some users, which are the couriers and depot servicemen. They are using smartphones to connect to the system. A smartphone communicates with the COM box, which we call S-box. And the S-box is connected to a logistics center, which is a part of the backend. And another part of the backend system is control center. Then we have the vehicle or the van here. The vehicle consists of two main parts. One is the COM box or the V-box, which interacts with the backend system, and also the vehicle stack, which communicates with the COM box and get the status and get the commands and performs it on the vehicle. So as you see here, the system users, courier, and depot service interact with the system via smartphone and a COM box, which we call S-box. Vehicles also interact with the system, with the backend system using a COM box, which we call V-box. And the backend system, which consists of control center and logistics center, acts as a backbone to the whole system and manages couriers, vehicles, interactions. So the rules and components of such architecture are as follows. The logistics center, its task and role is to manage and monitor couriers, parcels, and also handling the navigation maps. The control center, its main task is to monitor and supervise the delivery vans and handle unexpected situations regarding these vans. Then there is a user COM box or S-box, which acts as an interface between the courier's smartphone and the backend system, specifically logistics center. Then there is a smartphone app with which the users can get the status from the van and also send the commands to the S-box to be sent to the van. And then there's the vehicle V-box or vehicle COM box or V-box, which gathers van status and relays them to the backend system and also relays received commands to the van to be performed. And in the end, there's the vehicle stack, which interacts with the vehicle sensors and actuators to send status to vehicle and also deliver the commands to the vehicle. So in such an architecture, there are two main communication paths. The first one is the primary communication, which is shown here with a red arrow. So it's a two-way arrow between the S-box, logistics center, control center, and V-box. So this primary communication is established via cellular network. So the communication between the COM boxes and the backend system is using cellular. So here we have a cellular communication network, and here we have cellular network. So the S-box from courier domain and the V-box from vehicle domain have access to the cellular network. And the communication between logistics center and control center is established via local area network or internet. And every message between SBox and VBox is relayed through logistics center, control center. So if the SBox wants to send a command to the VBox using the primary communication, it should go through the backend system. And also if VBox wants to send some updates to the SBox, it goes through the backend system. So this is the primary communication of the system. But as we said, the communication between the COM boxes and the backend system is via cellular network. And as we know, in some areas, the cellular network might be temporarily or permanently unavailable. For such situations, we are using a secondary communication path, which you can see here. So in order to improve the system reliability, a secondary communication path between SBox and VBox is designed. And this security communication is based on LoRa protocol. So if in a situation, the COM-box from the user or SBox and the VBox are not able to communicate with the backend to send something to the VBox and vice versa, they can use this secondary communication mean to deliver this status and commands. So here we want to talk about the interfaces and protocols of the system. So the first protocol is BLE or Bluetooth Low Energy, which is used to interface between the smartphone, the user smartphone and SBox. So the data here is exchanged using Bluetooth Low Energy. Then for the cellular interface and also the LAN communication between the backend system and the cellular interface between the VBox and control center and SBox and logistics center, we are using the REST requests and responses. So as you see, the REST is based on 4 basic HTTP commands: put, post, get, and delete. So we are using these 4 requests to send the data, send an update, or send some commands. So the REST is used for communication and within the backend and within the backend system. Also between the SBox and VBox, which is the secondary communication, we have the LoRaWAN. And within the vehicle, between the VBox and the vehicle stack, there are ROS or robotic operating system topics which are exchanged. So every message is propagated or published by an entity, and the other entity is subscribing for the topic to get the data. So these are the overall protocols of the system. So for WAN Assist project, there are some security considerations that should be considered. First and most important is entity authentication. So the access to unauthorized users should be prohibited. So we have several points that this entity authentication should be implemented. First is between logistics center and control center. That means inside the backend system. Then between the SBox and the backend system. So SBox logistics center and SBox control center, there should be authentication. Then between the VBox and the control center, entity authentication should be performed. And finally, when we are using the secondary communication, there should be entity authentication between SBox and VBox. So this is the first security consideration. And the next the second security consideration is data confidentiality and integrity, which means all exchanged messages between the entities inside the system must be encrypted. No message should be sent without encryption because, as we said, we are working on a public network which is accessible by everybody, and therefore not a single message should be sent without encryption. So here we want to talk about the security domains of the security system. the overall architecture of the WAN assist is divided to 3 different domains. So first we have the backend domain, as we talked, and the backend domain consists of logistics center and control center. As you see here, you can also see the trust anchors and the certificate and private keys that shows which entity can authenticate which entity. Then we have the second domain is the courier domain. The courier domain consists of SBox and smartphone, which are inside the courier domain. And then we have the vehicle domain that consists VBox and vehicles. So we have vehicle domain, backend domain, and courier or user domain. Okay, so for the implementation of the security, as we discussed, we have some consideration that should be implemented. The communication between logistics center and control center is secured using TLS certificates because we are using HTTPS protocol to send REST messages. We are using TLS certificates. With these TLS certificates, logistics center and control center can both authenticate each other and encrypt their messages. Between SBox and logistics center, there is a challenge response mechanism with which the logistics center can authenticate an SBox, which we explain later. Between the SBox and control center, again, the TLS certificates are used to do this, to perform the security needs. And between the VBox and control center, also we use TLS certificates. And for the secondary communication, which is between SBox and VBox, we are using pre-shared key via primary communication. So in the beginning and in the initial phase, a pre-shared key is shared with SBox and VBox, and when they are using the secondary communication, they use this pre-shared key to authenticate each other and also encrypt their messages. So here, the right-hand side, you can see the authentication between a logistics center and control center. So you can see the message diagram, how this authentication is done. So in the beginning, as we said, this is a TLS-based authentication. First, the control center verifies the logistics center certificate, as you see here. Then the logistics center verifies control center certificate. And after this authentication from both sides, a session key is exchanged and the communication is encrypted using this session key so that nobody can see, nobody can decrypt the messages which are on the public network. So for the authentication of SBox and logistics center, as you can see here in the sequence diagram, when the apps starts by the courier sets and sends the username and password to the courier app, and the courier app sends an authentication request to the SBox. When SBox receives this authentication request, first it wants to make sure that it's connecting to the right backend system. So it first requests for the backend authentication token. This backend authentication token is created in control center and forwarded to the central logistics center and then forwarded to the SBox. The SBox verifies this authentication token, and after verification, it requests for authentication challenge from the logistics center. The logistics center generates and sends a challenge for the SBox, and the SBox must answer and respond to this challenge using its username and password. So the SBox generates and sends the corresponding response, and then the logistics center verifies. In the end, the logistics center verifies the response and authenticates the SBox. And in the end, we have the authentication between VBox and control center. For the authentication, first the vehicle powers up, and after the power up, it authenticates. It sends the authentication request with the VBox, and the VBox forwards this authentication request to control center. It also sends the VBox certificates to the control center. The control center verifies SBox certificates, and if it's verified, then the VBox is authenticated. When a VBox is authenticated, if the corresponding SBox is also online, an app token is generated and sent to both the VBox and SBox. And as we said before, this app token is used for when the secondary communication is used, so that they can authenticate each other with this app token and also encrypt their messages using this app token. So here in this slide, you can see the requests that are generated by every entity, which we name the security commands and requests. So from the SBox side, we have a get method called auth token. With this method, the SBox retrieves the authentication token from control center to verify the backend system and the logistics center. Then we have get auth challenge. With this method, the SBox requests for authentication challenge. Then we have post authentication. With this method, the SBox provides the authentication response. And then we have drive to position, which is a put method to send the vehicle to a specific location or position. Then we have status to change the status of the vehicle. We have parcel all to get and load all parcel data. We have parcel delivery success to confirm a success delivery of a parcel. And we have parcel delivery failure to confirm that a parcel has not been delivered successfully. On the logistics center side, we have app token post to send the app token to SBox. We have driving system status to push the current driving system status of the vehicle to the SBox. We have car pose or current position to push the current position of a vehicle. We have current target position to push the current target position of a vehicle, and all of them are going to SBox. We have connect to establish the connection between control center and logistics center. We have drive to position, of course, to send the vehicle to a specific position, and we have status to set the status of a vehicle from operational point of view. So continuation, in the control center connector side, we have put current position to forward the current vehicle position to send it to the SBox. We have current target position and driving system status. Both of them are sending the vehicle target position and vehicle status to the SBox. We have app token post to send the app token to the VBox. We have app token delete to delete the current app token from the VBox. Then there is drive to position to send vehicle to a specific position. And then state control to change the status of the vehicle. And finally, on the VBox side, we have post authentication to delete, to authenticate with the control center. We have put current position to send the current position of the vehicle. We have current target position to send current vehicle target position. Driving system status, which is used to push the current driving system status of the vehicle. We have camera data put to send camera data to control center, and also LiDAR data put to send LiDAR data to control center. In the implementation phase, in order to implement such a communication between different entities, we needed all the entities to see each other inside the public network. Therefore, a VPN has been established. So the VPN server is located in the logistics center, and all the entities, which are the courier, COM-box or S-box, and the control center connector and the vehicle COM-box or the V-box are connected to this virtual private network by establishing a VPN connection. Therefore, they are all seeing each other inside the network, inside the private network, and can send data to each other. And yeah, you can see here the overall architecture considering these VPN connections and also other protocols, the BLE communication between the smartphone and S-box, which we talked before, the REST interface, and the ROS interface between the control center connector and the control center app. And also here, a ROS connection between the VBOX and vehicle stack. So here you can see the overall state machine of the logistics center. It consists of several states, and the logistics center goes through these states for every vehicle, for every van. In the beginning of the day, the van is in the initialized stage, and then it goes to the technician control, and more specifically to the inspection status. And if there is a problem with the van, it goes to the inspection failure state, and if not, it goes through available state. When it goes to available state, it means that it's available for being packed. Therefore, in the next step, it goes to the packing station, into the depot. And when it arrives to the packing station, it changed the state to getting packed. And here it gets packed. And then when it's, the packing is finished, it goes to ready state, which means that it's ready for the day. When it's ready, the next state is going to the meeting point or driving autonomously to the meeting point. When it arrives to the meeting point, the state changes to waiting for courier. When the courier comes and drives the vehicle goes to in delivery state, and at the end of the day, when the delivery is finished, it goes back to the depot. And when it goes back to the depot, if there are some parcels which are not delivered, it goes to the unpacking station. And if not, it goes to unpacked status. So anyway, when there is something to be unpacked, after unpacking, it also goes to unpacked and again goes to inspection for the next working day. So this is the overall state machine of the logistics center. For the implementation, here you can see the software architecture for every entity. So for the logistics center, on the driver layer, we have the file system, the Java Web Token for creating the app tokens, and also Express.js, which is used for handling the REST requests and messages. And on the top layer, on the application layer, we have user or courier management, we have parcel management, we have fleet management, and navigation maps. In the control center connector software, we also have two layers. On the driver layer, we have file system, we have ROS driver to handle the ROS published topics and also subscribing ROS topics. We also have Java Web Token to take care of app token and authentication token. And we have Express.js to handle the REST requests and responses. And on the application layer, we also have the fleet management to manage and monitor the vans and also the control center interface. For the implementation of COM-boxes, here you can see the S-box in the SBox, we also have, in the software, we have 2 layers. On the driver layer, we have file system, Java Web Token, cellular driver to handle the cellular network, Bluetooth Low Energy driver, or BLE to handle the messages which are exchanged between SBox and smartphone. We have Express.js for REST messages and LoRa for the secondary communication. And on the application layer, we only have app backend interface. In the VBox, in the driver, we have, in the driver layer, we have file system, Java Web Token, cellular driver, ROS driver, Express.js, and also LoRa. And the application, in the application layer, we have vehicle control center interface. So in order to integrate the whole communication system, we have gone through several steps. So the first step was implementing and testing the individual units, which are the COM boxes and control center and logistics center. Then it comes the REST interfaces. We have tested the REST interfaces between SBox, logistics center, control center, and VBox. And at this stage, the WAN has been emulated using a simulator. Then the next stage is implementing and testing ROS interfaces. The ROS interfaces between VBox, vehicle, and inside control center have been implemented and tested. Then there is the LoRa interface, which is used for secondary communication. The LoRa secondary interface between SBox and VBox has been implemented and tested. And the final stage is testing all the interfaces with backend system and vehicle enabled. Here you can see the hardware of the COM boxes. So for SBox and VBox, we have used a common base platform, which is Raspberry Pi 3. And they are enjoying a common cellular shield and a separate LoRa shield for VBox and SBox. For the SBox, we have LoRa device, and for the VBox, LoRa concentrator. And they are both using the Ubuntu operating system and the software modules, for example, Node.js, in order to easily integrate them with each other. And the hardware of logistics center and control center connector is an industrial PC. The internet connection for these entities are provided using Ethernet. They are also using the Linux operating system, more specifically Ubuntu. And they are also using common software modules, for example, Node.js and so on. So in order to have a summary from this presentation, we can summarize that in the first step, communication and security requirements of the system have been specified. Then, according to the requirements, system architecture has been designed and system entities have been defined. Then the primary and secondary communication passes have been designed to improve the system reliability. Then the system has been divided to several security domains to increase the security. The different authentication and encryption mechanisms have been employed to ensure system security. And in the end, the system has been implemented with these considerations and tested step by step from unit test to comprehensive test of the integrated system.